Okay, let's sketch a cubic. Okay, let's just go with the cubic, so it's going to look something like that. We're going to have to find our, we're going to find our x-axis intercepts by factorising. We're going to find our maximums and minimums through the first derivative. We're going to verify which one's maximum and which one's minimum through the second derivative. Is that it? Yeah. Oh, and the y-axis intercept. That's what we've got to do. Okay. We're going to find the first root, the first zero, the first factor through guessing. We're going to start at 1 or minus 1. Can you see that 1's not going to work? So my bet is it's going to be minus 1. So what's minus 1 cubed is minus 1. Minus 1 times 1 is 1. Plus minus 1 squared is 1. Plus 15 minus 25 equals 0. Sweet. So we've got our first factor, x plus 1 minus okay. X cubed divided by x is going to be minus x squared, multiply through, subtract, and then bring down. 10x squared divided by x is just going to be 10x, multiply through, subtract down, and then bring down, divide, so by x is going to be minus 25, minus 25x. Excellent. We get nil, so that's a neat factor. So we've come to x plus 1 that's where we're at. Don't really like that. So let's go y equals minus. We don't like that negative there, do we? We need to factorise that. That's the perfect square pattern. Y equals minus x minus 5 squared, or don't really care how you see it. So when we set y equal to 0, by our null factor law, x will equal minus 1, 5, or 5. Minus 1, 5, and 5. So, minus 1, 5, and 5. So it's going to come scorching down there, up, and then we know pretty much that's what it's going to look like, don't we? But we've sort of got to prove it mathematically. X-axis intercept's done. Y-axis intercept, you can do it back there. So we're going to set x equal to 0. 0 plus 0 minus 25. So it's going to be 0 minus 25. This isn't an exam, so I'm taking some shortcuts that you won't in your test. Full setting out, please. Okay. We are going to need to find our stationary points. So we need to find this point and that point. That's a bit of a joke anyway. We've got to find it anyway. Do we want a triple product rule? No thanks. We're going to differentiate that to minus 3x squared plus 18x minus 15. And we're going to set stationary points happen with a slope equals 0 let's just divide by -3. That will be x squared plus 5. X minus 1, x minus 5. So we get stationary points where x equals 1 or 5. Specifically 1 watt and 5 watt. Let's put this 1 back into this thing here. I'm going to use a calculator. 1, so it's going to be -1 plus 9 minus 15 minus 32. And I think we know what that's going to be, but do it in the calculator anyway. -125 plus 9 times 5 squared minus 15 times 5 minus 25. Does anybody know what I'm going to get? Let's go 0. So we've verified now. I guess I'll just use my highlighter. That was the 5, 0. And that was the 1 minus 32, which it looks reasonable to me. I'm pretty happy with that. Nothing's really upsetting me there with that. Okay, the other thing we've got to do, although it's silly, we need to prove that that's a maximum and that's a minimum mathematically. Clearly we do know that is. So y double dash, what's y double dash? 2x minus 6. Y double dash of 1 will be negative, a negative person, therefore that's a maximum. What have I done there? You got to be careful, don't you? You got to be careful. That's not y double dash. Got to be so careful. There's my y dash. So y double dash will be minus 6x plus 18. So y dash of 1 will be minus 6 plus 18, which is positive. I'm a positive person, therefore that's a minimum. Is 1 negative 32 a minimum? Yes. Whew, glad I picked that up. Y double dash of 5 will be minus 30, which is negative. Therefore, that's a maximum. Okay. What else? I haven't left myself any room here, but we've got to find where y double dash is 0. So we've got y double dash. So we're going to find our point of inflection. So set our second derivative, x equal to 0. And x will be 3. So let's put 3 into this function. 3 into this function here. 3 plus minus minus 16. Okay, so 1, 2, here's the number 3. So right there is our point of inflection, and that happens at minus 16. So there's our graph, y-axis, x-axis, and there's our function. All mathematically proven. We've got our turning points, we've got our point of inflection, we are good to go.